Hi, I'm Keith Kurak. I'm a developer success engineer with Expo. Prior to that, I spent several years building apps with React Native and Expo tools. This fella on horseback right here is actually a picture of me when I built my first Expo app. So I'm familiar with their grandma and pa's Expo and how Expo has evolved significantly since times of old, and I'm here to explain why it's not your grandparents' Expo anymore. We gather here today to reapproach and or put to bed once and for all the historically oft asked but poorly premised question that our search engine results will just not let go of. Should you use regular, React Native, or Expo? If you go far enough down the rabbit hole, you'll find any number of misconceptions or half-truths about either option. Pick your favorite. For new developers, the Discord fueled perceptions of two divergent paths that you must decide between before you hit File New Project. One with limitless power beyond the capabilities of most of us to control, and another that tames said power, bringing it within reach of us normie developers, but at the expense of tethering us to training wheels we were likely to grow out of. Trying to cross between these two paths is only for the brave and or crazy, with the dreaded eject being one of the most traumatic events a cross-platform mobile developer can face. These perceptions, exaggerations, tall tales, and in a few cases, realities, belied a more fundamental question that we were all trying to answer. As a React Native developer, how does native code fit in your workflow? In ancient times, way back during the tail end of the Obama administration, we had React Native, and the promise was that you could write native apps with, say, I'm just making this up, 97% JavaScript, and fill in whatever else with native code and customization. While, say, 3% native or whatever it is isn't much, depending on your comfort and experience with two very different native platforms, that could be an awful lot of native pain. A high barrier for a key audience that might really want to make native apps with only JavaScript, say web developers. Then comes along Expo with the goal of eliminating that barrier to entry by enabling a 100% JavaScript workflow by way of a one-size-fits-most native template with most all of the extra goodies a typical app would need. Built in the cloud so you don't ever have to touch Xcode or Android Studio. Native paid and gone, but at the expense of the native gain for anyone who might need to go a little further out of the box. In the intervening epoch, which actually was only a fraction of the total lifespan of Microsoft Zune, the children grappled with each side. The React Native devs occasionally wondered if they were writing too much native code, questioning if JavaScript was just a third language in the pile to grapple with. Meanwhile, as the React Native ecosystem grew, Expo devs wanted just that one extra package or to tweak that one little extra bit in Xcode. Grandpa's Expo toy box expanded, but the kids always wanted more. Born of this intergenerational struggle was modern Expo, a workflow that lets you work entirely in JavaScript, even while adding native modules outside the Expo SDK, and even lets you customize with surgical precision your native projects with JavaScript-based configuration and plugins. Yet it also has the flexibility to work for traditional React Native projects while you maintain full control over your native code. Today's Expo is a set of knobs for your React Native workflow. Turn up or down native customization, turn down the complexity in bringing on new developers and testers, speed up local development, add cloud services to scale builds and deployments. Expo isn't an all or nothing monolith, but a series of modular multiplier factors on top of the foundation of stock React Native. Using Expo is now using whatever Expo tools are the right fit for your project at whatever stage it's in. To understand just how we got here, let's take a second look at that history we just zoomed through, putting a magnifying glass on just how this new Expo came to be. Foundationally, Expo is about improving your workflow as you move through developing, reviewing, and deploying, making these steps faster, eliminating dependencies and barrier to entry, reducing error rates, etc. Expo has kind of always been about this, starting from the true north of web development's workflow. Not that web development is perfect by any means, but there's some really nice things about it. You can start up a local server to work on your app in just a few seconds. You can code everything in JavaScript, the lingua franca of the internet. When you want to test, drop some files on a server. When you want to deploy, drop some files on a different server. So the goal all along has been a mobile workflow that feels right at home for your average web developer, despite all the things inherent to mobile, from native compilation to OS restrictions, which make that difficult. Write JavaScript, publish JavaScript, run JavaScript. So as we compare the old workflow and its evolution in the new workflow, we'll use these develop, review, deploy steps as a guide to compare, along with who couldn't use the workflow in the first place, or as we used to say, when you would have to eject. So let's start with original Expo, Grandma and Poppy's workflow. 100% of your code was in JavaScript, And any configuration of your native project, names, icons, splash screens, permissions, etc., that was done with an app.json configuration file. You would start a Metro server that would stream your app to Expo Go, which contained a veritable smorgasbord, a kitchen sink of native APIs. This was the native runtime behind your JavaScript. Likewise, you would build your JavaScript into a bundle and publish that to a URL, and the Expo Go app could run that. So anyone testing your app could do so that way, which was faster than building the entire app and generally good enough for all but the edgiest of edge cases. Finally, to build your app for the stores, you would publish your JavaScript one more time, and then the Expo Cloud Builder would inject your bundle into the native runtime used by Expo Go, except this time as a standalone app. This enabled a 100% JavaScript native mobile workflow for a whole lot of developers, many use cases. You didn't have to touch Xcode or Android Studio. You could technically run this on a Chromebook. Not that anyone would try this. However, there was a single native runtime, a single collection of native modules for each Expo SDK. This meant that the workflow could work with anything you could do with JavaScript only, or anything you could do with the native modules that were already in the Expo SDK, but not any other native module. So, eject. Wait, I'm sorry. It just froze. Wow. There we go. Eject. In some cases, maybe you could work around that one missing library, getting a little creative. But in other cases, that functionality just wasn't available, so you had to eject back to plain React Native, running your own builds, etc. One of the apps I worked on in this era required HealthKit, which was a total no-go for inclusion in the Expo SDK due to restrictions on Apple's end. This illuminates another smaller limitation of that single runtime. Your apps would include all the native code in the runtime, even if they didn't need it. This single runtime was an important part of making the original Expo work for so many people at the time, but there was a long way to go. The next stage in the journey required a slight detour. We had a 100% JavaScript workflow, but we needed a more flexible runtime to make it work for everyone. You need to be able to add any native code you need and remove any native code you don't. So that was actually the first step, splitting into two workflows, Manage, basically what I just described, and Bear, which was more or less the base React Native workflow, except that it would work with the full Expo SDK, supporting things like updates, notifications, and cloud builds. With Bear, even if you couldn't use the entire original workflow, you had a much nicer place to land if you ran into a limitation. Plus, reapproaching the problem in this way was a necessary step for creating EAS Build, which it's easy to forget that in its first iteration, EAS Build only worked with Bear workflow. But a super flexible cloud builder that worked really well with any React Native app was a vital foundation for reliably building runtimes that could support JavaScript-only development for any use case. Going hand in hand with this was making the Expo SDK modular enough that even complex things like updates could be added like any other native module to this new build pipeline. Once you have a system that can build any React Native app, it makes a lot of sense to take that managed workflow and instead of using its custom fixed native runtime, make it something that can feed right into this new build system. This required a really good configuration sync. Something that could take all those important customization points in your app.json file and create a Bear React Native app just prior to build. So Managed and Bear really aren't all that different after all when it comes to what they're made of. The timing is just a little different. The new magic that puts Manage on the same build pipeline as Bear happens just before build, so we called it, ta-da, pre-build. Two significant differences remained between Bear and Managed workflows. Bear didn't have its own Expo Go, a test build that could quickly launch any JavaScript compatible with its native runtime, whether from your local environment or an update. So we added that. They're called development builds, and they work a lot like Expo Go, except the native stuff on the inside is customized to your app. Meanwhile, Managed Workflows pre-build couldn't create any possible native project. It could sync the myriad of customization points in your app.json, or what we call the Expo config, but it couldn't do all those manual steps that were required by many native modules. Add an entitlement here, tweak Android manifest there. So we added that to pre-build. We call them config plugins, and they let you write JavaScript that modifies any part of your native project just before build. So Manage and Build are starting to look like the same thing. Thanks for pointing that out, Beasley. So today it's one workflow with options. You can choose to use the Expo CLI or the React Native Community CLI, choose to adopt pre-build or manage your own native projects, choose to use development builds. Regardless of how you set up your development environment, you can use EAS Build in the cloud or EAS Build locally, or bring your own build pipeline. Regardless of your development environment or build system, you can use EAS Update as part of your review and deploy workflow, or not, it's your choice. So this is why we don't really use the word eject anymore. You're kind of already in this workflow no matter what you use. There's no reason to leave it, just perhaps reasons to choose different options. Hence, no more React Native versus Expo, no more React Native apps, and Expo apps that are different enough to use different tools that incur significant switching costs as you move from the one to the other. Now, let's explore what it's like to move in and out of these different choices in the Expo workflow. To illustrate how Expo builds in the core React Native experience, we'll start with the barest of bare apps, something created with React Native in it. Then we'll track at each step how this project has been modified, and in some cases, not modified much at all, to take advantage of Expo tools. To chart this history, much like if we were in Grandma and Grandpa's basement, rummaging through their record collection to track their musical taste from the Beatles to Bon Jovi, we'll rummage through this project's PR requests. Now imagining my grandkids rummaging through my public PRs being like, "Ah, Papa's code, it's so quaint. I can't believe he wrote that by hand instead of using GPT-47. For our first step along the journey, suppose I want to use the Expo CLI and a development build. So I open a PR to add Expo modules, which for many projects can be done automatically with a single command, npx install Expo modules. We'll see here that this tool makes a very light touch, updating the native base classes so other Expo modules can start up without mucking up your app delegate or main activity like so much native code used to do, and tweaking your CocoaPods and Gradle to support deep auto linking. This is not a layer that bogs down your app or adds unnecessary bloat. Now that the project supports Expo modules, I can set up development builds, which let me build a native shell for my app that anyone can use in their local development environment without rebuilding. All I need to do is add the Expo dev client package and a URI scheme that the Expo CLI can use to invoke the development build. Now that we can use the Expo CLI to start Metro Bundler and launch a development build and be running instantly on a simulator, emulator, or device, my teammates can use the same build. They don't even have to have any native tooling now installed in order to work on the app. Development builds are one of the many things in the Expo workflow that exploit the different cadences for updating JavaScript in native code. We can eliminate build cycles by only rebuilding the native layer when it changes, which is usually less often than the JavaScript. One thing we noticed while adding development build support was that while it was pretty easy even without native projects, it would be even easier without them. It would literally be adding a module and perhaps tweaking configuration file, and that's it. So it feels about the right time to adopt pre-build, which will eliminate our checked-in native projects in favor of running pre-build to generate them just before build, based on a configuration file. How much work this takes will depend on how much you've manually customized your native projects. In my case, I noticed that other than names, icons, bundle identifiers, etc., my native project isn't that different from the defaults, so I can run pre-build clean to remove my native projects and replace them with an app.json configuration. So a lot of files changed in this diff, but it's mostly just deleting and git ignoring your iOS and Android folders. Now their customizations are expressed in a configuration file. Besides obvious stuff like app name, icon, splash screen, we can also set up our first config plugin, Expo build properties, to define a customization to our native project, in this case restricting it to more recent iOS and Android versions. When this app is built in the future, we'll run pre-build first to generate the native projects, link native dependencies, apply our app.json config, and then apply any config plugin customizations. You can probably see how this is a pretty big win for the ease of upgrading. Instead of the native project being this not quite fully understood blob that might break in unexpected ways as we upgrade, our native projects are expressed as customizations on top of a default template. The iOS and Android folders are more like node modules now, being restored just in time based on a configuration file. Until now, all we've been doing is integrating Expo libraries and CLIs into our local environment. Next, let's jump all the way over to the deploy side of the workflow and talk for the first time about using that foundation to take advantage of Expo application services, EAS build and EAS update. We're happy that pre-build has made upgrading and maintenance easier, and development builds have made it quicker to spin up an emulator or simulator for working on the app locally. But it'd be really nice if we could plug this into a build pipeline that could manage credentials for device builds for me, auto-submit to test flight, and make it possible for anyone on the team to build without actually setting up everything on their local machine. So I created a PR to add an EAS build configuration. This involves installing the EAS CLI and initializing EAS build, which creates a JSON configuration file where we can set up our build profiles. A handful of profiles useful to development and production will already be defined right out of the gate. Now we can kick off a build based on a simple build profile defined in that config. Whether you're doing ad hoc builds for your dev and test team or production builds, it supports tools for automatically managing credentials like certs and provisioning profiles. Nobody on your team has to have those configured on their machines anymore. It can also auto-submit right to test flight via the auto-submit flag. Finally, and really important point here, it's not a mystery what this thing is doing. It very thoroughly logs each step it's taking. Adopting this build pipeline does not tie you to a particular vendor. You can walk through this step by step. You can run it on your local machine, stop it in the middle, inspect the files to troubleshoot something. Conversely, adopting a particular vendor doesn't tie you to the workflow, as you can inject your own custom steps into it. You can also define webhooks so that it can call out to your CI once finished. Oh yeah, an EAS build doesn't actually even require the Expo modules we were talking about earlier or any Expo dependencies. It'll work with any React Native app, and really even native apps that don't have React Native at all. So adding EAS build streamlined our process for deploying internal test and store versions, but there's only so much you can do to speed up a full store submission. Like there's Apple review, and don't ask me to prove it, but I swear Google Play Store review is even slower than Apple now. I really want to release critical updates like bug fixes right away. Like just upload it to a server and users will get it as soon as they reload their app. You know, like kind of like a website, I guess. So let's add EAS update by running EAS update configure. This will add just a bit of configuration to your app.json, instructing the build pipeline that your app is now using updates. Then you define which update channels go to the build profiles in your EAS JSON. Channels are basically a way of separating updates between testing, production, and other scenarios, so you can update preview without touching prod, etc. We're once again taking advantage of the distinction between the JavaScript and native layers by building a new JavaScript bundle and publishing it to the cloud, which is way faster than a native build. Not to mention the time and App Store review. Your app will check either at launch or on demand to see if there's a new bundle that matches its channel, runtime, version, and platform. And if so, it'll download it, reload, and start using that new JavaScript. Your users can have critical bug fixes in minutes. Like EAS build, this is not some black box, but an open protocol, the Expo updates protocol. We think we do a pretty good job of hosting it, but if your business has specific needs, you can host your own update server. So like with EAS build, just because you adopt this workflow or functionality does not mean you cannot adjust course later. It does not mean that you're tied to a specific vendor. Finally, let's hop back to the middle, the review step, and put all these tools together we've used to make a really great flow for testing changes to your app. Development builds can not only run JavaScript from your local environment, but they can also run updates. You can set up a CI like GitHub Actions to run EAS update when a PR is updated, naming the update branch after your PR. The bot will then post a QR code link to the update in your PR, which a tester can run using a development build. Therefore, you can automatically publish per PR test versions of your app that anyone can run in seconds. So now that we've just doused you with the Expo fire hose, maybe you're thinking, okay, some of that's cool, but where the heck do I start? If you've got an existing app that's been chugging along without Expo tools, we totally understand that you're not going to move all your cheese at once to achieve the workflow we just described. We wouldn't recommend that, even if it benefits us. But remember, Expo equals a bunch of modular multiplier factors, so you can take advantage of any one step in here that resonated most with you and give it a try to see how it goes. EAS build works with any React Native app. No Expo modules required. The only additional commit you'll make is a configuration file. The free plan gives you more than enough builds to see if it's a good fit. You can make a development build to speed up your local development workflow. You could try to make your app pre-build compatible. You don't actually have to delete your native project folders to start using pre-build. You can run it on your own to sync configuration between app.json and your existing native projects, gradually moving native customization over to the Expo config. And finally, long-standing complex apps that often involve increasing amounts of native custom code. If you're in that boat, the next time you need to harness native code for a feature, you may consider the Expo Modules API, available to any app that adds Expo Modules support, as we demonstrated earlier. The Expo Modules API is a streamlined way of writing native modules, allowing you to use very minimal boilerplate and write all of your native code in Swift and Kotlin. No inscrutable compiler directives, attributes, etc. Just write a class and it's available to your JavaScript. If you're starting a new project, of course it's easy to kick things off with npx create expo app, giving you Expo modules, the Expo CLI, pre-build, easy configuration for development builds, EAS build, EAS update, and more right out of the box. Or you could have all of that and the next generation of bringing the best of web development to mobile. including file-based routing and deep linking as a first-class construct by starting your next project with Expo Router. When you start your project out with the Expo Router template, you have a project ready to build your navigation stack simply by adding files and folders. Each of those routes corresponds to a URL, enabling universal deep linking across mobile and web. And as nice as that sounds, it'd look even better if I actually show it to you. So let's do that. Hey, code. All right, so here's a quick example project with a stack and some tabs. So of course, the files are your screens, and the screens are your files, very minimal boilerplate. You can use these layout files at each level to customize how the screens arrange themselves, whether that's adding a default React navigation bar, as we have here at the top level. Oh, that's a little too much console there. So that's defining our navigation bar there. Or if you want to define the tab layout, you see here in the tabs folder, I have a very simple thing that says my layout is tabs. So we have things started up here. You can see I can navigate amongst the tabs, and I can navigate amongst the stack. And oops, the route isn't here. But instead of like erroring out, I'm able to define like a dynamic route with this little like square bracket missing ... thing here. So any route that doesn't go to something already can do that. I can add this missing screen, and since I'm not crazy enough to actually live code the new screen, I have them copied over here. So let's drag in the correct screen. Let's refresh. And now all of our words. So our dynamic route is now like pushing each word onto the stack with this link component that basically says, hey, here's a URL, go to that URL, and you can access that part of the URL as a parameter. Over here, it's easy enough to add an additional tab. Let's just grab tab number 4 in here. And now we got 4 tabs. So there's 3 things I quite like about Expo Router. Number one, like URLs are everywhere. The folder structure represents the address to that particular screen. This makes deep linking to individual screens in your app work right out of the box. And you already have full URL-based routing if you target web. This is all a little more immediately obvious if I run the app on web. So let's do that by hitting the W. And while that's loading, speaking of targeting, oh, it's already loaded. Expo Router works great with Metro Bundler's web support. If you previously ran an Expo app with web support, you may recall it starting up a separate Webpack bundler so your web app would, it was like a little bit slower, and Metro and Webpack don't always work the same, but now it's using the same bundler, so it starts up real fast, and often it's like going to work exactly the same. It's much more often without you having to do additional configuration and troubleshooting. And we announced even more web-friendly features at App.js for Expo Router 2.0, like SEO, handoff from iOS, worldwide searchable static routes, first-class support for CSS, Tailwind, Sass, and other styling systems, and a lot more. And finally, Expo Router is based on React navigation under the hood. Those layout files that let you plug into advanced React Nav features, so you can configure your tabs, stacks, drawers, and whatever to your heart's content. So if you see an option on the React Navigation's docs, it should work with Expo Router. And that's it for Expo Router. So I wanted to thank you so much for joining me on this journey from the Expo of yore that our ancestors shared around the globe of their CRTs to today's Expo tools and all they can offer for your React Native app. If you're interested in those PR examples, you can head over to bit.ly/notgrandpa'sexpo. You can check me out on Twitter at LlamaLover, and thank you very much.
Awesome, man.